Hello, Mr. Colati here. Today we're going to be looking at least squares regression. Now if you remember in the last lesson, 4.7, we looked at finding the line of best fit and some different ways of calculating the line of best fit. This was okay, but the problem was that it was a little bit subjective. Everyone's line of best fit might be slightly different depending on the points you chose. So we're instead today going to find a more robust way of finding the line of best fit, which is called regression. So that's the process of fitting a trend line to data mathematically. It's called regression. Regression is the kind of adult term. Another way of saying this is that we're finding the line of best fit. As we said before, in this course we focus on linear regression. So that's where we fit a linear model to the data. This works in a lot of situations. A lot of relationships we study happen to have linear correlations. So that's this course. However, the technology that we're going to show you how to use today, it can do more advanced regressions. We can do quadratic regression, so where we fit a quadratic model to the data. Do logarithmic. This one here is exponential, which is very another common regression. So your Microsoft Excel, your GDC can do these regressions as well, but this course, like what you would see on an exam, would focus on linear regression. Now, when you guys do your math exploration, your IA, you might encounter something like this, so the same procedure would apply. So let's talk about how linear regression works. So what we're going to do is, okay, let's look at the line. These are some data points, and here's the line of best fit. Now this is the true line of best fit. And look how each point is a certain distance from the line. So look at this. I can measure how, or figure out how far each of them is from the line. That distance is called the residuals. So a residual is defined as the vertical distance between a data point and the regression line. If you have a positive residual that is above the line, and if you have a negative residual that is below the line. Now, much like we've done before when we found the standard deviation, to find the best regression line, I would want to choose this line so that my residuals are smallest, right? So that these amounts are minimized. That would be the ideal line. So imagine I've got the perfect line, then I would want to make sure that I've minimized this amount. The predicted value from the regression line, subtract the actual data point. So that is the y value on my curve minus the y of my data point, right? That's the residual. So for this point, it would be this value y on the curve on the line, subtract the data point yp. Now, if you do that with all the points and then you're trying to minimize it, well, you're gonna have a problem because this negative residual counterbalances this positive residual, and they just add to zero. That was sort of the problem we had when we did standard deviation. So what I'm going to do to eliminate that negative, I'm going to square this expression. So I did that, squared to eliminate the positive negative. Okay. Next step is I'm going to add up all of these residuals. So essentially, I like to draw this. Essentially, I'm adding up, these square areas. right? Because I squared these amounts. So I'm adding up all of these areas. Oh. So I use that summation notation. So I'm summing up all the residuals. Okay, now remember, y is the point from the line, and this line, the equation of it is mx plus b. So I'm actually going to replace y with mx plus b, subtract the point. So I'm going to sub in the equation of the regression line. Okay, so now what I need to do is minimize this, right? This is all the residuals added up, and I want to minimize, I want to make this sum the smallest. We actually can't do that with our level of math. This would require university level math. So we're just going to put a note, find an m that minimizes this sum. And that's going to be done using university level math. Okay, and there it is. When I use my university level math, which someone else did for us, then we find the slope of the regression line is this. It's sum xy, which is the sum of x times y minus sum of x times sum of y over n, over sum of x, which is sum of x squared minus sum of x all squared over n. So it's a bunch of formulas, but essentially I can now find the slope of the best regression line, and we would all find the exact same value. It's always going to be this perfectly minimized amount, or this amount that minimizes those residuals. So now I have these formulas. Let's try using them. Oh, sorry, I meant to say this process is called least squared regression. Least squares regression. So, and that's exactly what I'm doing. I'm trying to find the smallest value. Okay, so now I have these equations. Let's try using them. So what is the regression line through these points? So I'm going to use that formula I was given, which is sum xy over sum of x squared. So now we actually need to figure this stuff out. So sum xy. Well, if you looked on the other side, it was sum x times y minus the sum of x, the sum of y over n. And sum x squared is the sum of x squared minus the sum of x all squared over n. Okay, now the way I like to figure these things out is make a little table. So there are all my x values and all my y values. 1, 3, 2, 1, 3, 5. Let me draw a little table. Okay, so when we say sum of x, y, what we're actually saying is take all the x times y's and add them up. So x times y, 1 times 3 is 3, 2, 15. If I add them all up, the sum of the x, y's is 20. So I can sub that in here. 20 minus, then I need the sum of x's. That means add up all the x's. Well, that's 6. And all the y's is 9. So I have 20 minus 6 times 9 over the number of data points, which is 3. That gives me something over 3, so this is 60 over 3 minus 54 over 3, which is going to give me 6 over 3, which is 2. Okay, now over here we need the sum of all the x squareds. Well, x squared is just 1. Okay, 1 squared is 1, 2 squared is 4, 3 squared is 9, and then I need the sum, so I need to add them all up, which is 14. So I get 14 minus sum of x, which is 6, squared over 3. So I end up with This is over 3, this is over 1, so that's 28. That's 42 over 3 minus 36 over 3. That's 6 over 3, which is 2. And so now I can use my formula here. I have 2 over 2, which is 1. So all this work, and I have the slope of the regression line. So now I find the equation of the line with slope equals 1 and mean point. I'm going to use the mean point as my second point. So remember, the mean point is add up all the x's, divide by the total. So it's 6 over 3 comma 9 over 3, which is 2 comma 3. So therefore the equation of the line, if I use that short form for the regression line, it's 1 times x minus 2 equals y minus 3, or if I rewrite it in y equals mx plus b form, it's y equals x plus 1. There is the best regression line, the correct regression line that minimizes the residuals. Whew, it was a lot of work. So let's just make something clear. You're never going to do this ever again. We did it once. It's a once-in-a-lifetime experience, but you're never going to do it again. You won't be tested on it, because if you ever get a question where we need to find a regression line, you're just going to go to GDC. What we did here was just an experience where we did it once to see how it works. But let me put in big letters, and I can't say this enough. Always, always, always use the GDC to find regression line. So this process never done. This process is never done by hand on quiz or a test. Okay, so you're never going to have to do this. This was a once-in-a-lifetime experience. So knowing that you're never going to do this ever again, let me show you the technique I want you to use when you have to find a regression line, and that is using our GDC. So we're going to take out our GDC, and remember, up till now I've always showed you how to use the scratch pad to do quick calculations. This time we're going to be actually entering data into these documents, so on the kind of the right-hand side of the screen and along the bottom. The first way I'm going to show you how to do this is to go to the bottom and click add a new list and spreadsheets file. Now see how it kind of looks like a Microsoft Excel spreadsheet? That's how I remember. I press enter, and now it gives me a spreadsheet. Again, very similar to Microsoft Excel at this point. So I need to enter my data. So I'm going to enter my x in the first column and my y in the second column. Now you should scroll up and give your variables a label. You can do whatever you want. I'm going to use just, why don't I call this dist, D-I-S-T, for distance. So I just type it in, and then I scroll down, so that's next to the label button, that's label, and now I'm going to enter all of my data points. Now when you enter them, a quick way to do it is just type it in, so you guys can kind of see my screen here, 7.2, and then press enter. And if you follow that procedure, you can be pretty quick. 4.5, enter. 13, enter. 1.3, enter. 9.9, enter. 12.2. If we were in the class, I would race you guys, and we'd see who was fastest. But you want to be able to enter quickly but accurately. So there I've put in all 9 pieces of data. I'm going to scroll back up. Notice how the label is always visible. Now I'm going to go up to the column B, again to the top where it says label. I'm going to enter a variable name. Now time is sort of sketchy, like, oh, time should be okay. Some letters and variables you might be careful, you don't want to double define them, like E would not be a good label because E has so many other meanings for the calculator. But let me call it just time. I think that should be okay because it's a word. Time. And now again, let me enter all of my time points. So they are 17, 13, 29, 2, 25, 27, 41, 15, 53. Should Okay, there's all my data. It's all in pairs. Okay, so now I've entered my data into the calculator. So there's a few different ways now of manipulating the data to find the regression line. The first is this nifty kind of thing, the list and spreadsheet page. So I'm going to press the dock button. So remember, this is one of my all-star keys. The dock button allows us to insert, we go down to insert, another page. Now look, you can do all those different pages, a graphing page, a calculator page, a geometry page, and all of these pages will live in the same file. So this time I'm going to insert a graph. So go to graph. So look, see how at the top it says 1.1? If I want to go back to it, I could even scroll with my mouse and go to 1.1 and click, and there's the data. I go back, now I have, that was my first page of my file. This is the second page of my file. It happens to be a graph. The other way you can go back and forth is see how there's a blue for the left arrow and the right arrow? That's change page. So I just could press Control left or Control right. Regardless, now I'm in graphing mode. And what I want to do is use the data and graph it on this this axis. So let me escape, because I'm not entering a function this time. I'm actually entering data. So I'm going to press Menu, Graph Entry, and I'm not entering a function. I'm actually entering data to make a scatter plot. So I go down to number 6, press Enter, and now I need to tell the calculator, well, what am I going to use for my x's and what am I going to use for the y's? Well, it just so happened I created those things. X, those were my distance values. I called the variable dist. Look how the calculator typed it in bold, because it recognizes that I'm typing a variable that it's already seen before, it has in memory. Then time was my y. I press enter. Oh, sorry, the alternative you could have done is, instead of, if you don't remember the name of your variable, you could press this var button. This var button is all the variables that are stored in the memory of the calculator at this instant. If I type var, it says, oh yeah, you have these variables, distance and time, and they're little sets, which means they have a bunch of numbers. So I could scroll down and click time. That's a little faster than typing. This keyboard, we know, is really annoying. Now I press enter, and there. Oh, so is there something wrong? I only see one data point. Shouldn't there be 9 points? Is my calculator broken? No, your calculator is not broken. Probably what happened is the zoom is wrong, and I think that's most likely correct. It only goes up to x equals 10. So I'm going to press Menu, Zoom, and then what would make sense? Well, this is where data or fit can be really useful. I believe data will be the best, because it'll allow us to see all of, it'll make sure all the data is visible. Oh, there it goes. Now you can see there is a relationship. As distance goes up, your time increases as well. There's some sort of positive correlation. What we want to know is the line of best fit. So we're going to press Menu, and this is obviously something we're analyzing the graph. Nope, that's not what I'm doing. Okay, sorry, that's not correct. So that's the data. Let me go back to my spreadsheet page. So let me go back to 1.1. So press Control left, and now I'm back to my spreadsheet page. I want to calculate the linear regression of this data. So I'm going to press Menu, go Statistics, and then it's a stat calculation. Oh, look at all the options. There it is, linear regression. Now there's two options. Make sure you choose the first one, mx plus b. That's what we're most familiar with. But look, you can do all these other regressions too, like I told you, although those aren't in the course. So I go linear regression. Now, okay, it's going to ask me all these things. Well, first of all, you need to tell it what with a list of all your x values. Well, my x values, remember I called it time. I could just scroll to the left, and look, it gives me some options from the pull-down menu. So distance is the variable for x. The y is the variable's time. It's going to save the regression equation to F1. That's okay. Is there a frequency list that goes with each of these? No, the frequency of each of them is 1. Categories, I don't have to worry. I can just press enter, and whoa, some stuff appears in the next two columns. So there it says regression equation is in the form mx plus b, which is what we're used to. There's the m, there's the b. So now I could write out my answer. The answer would be using GDC. It's a good form to always tell me if you're using the GDC. Y is equal to, what were the numbers? 2.16x plus 1.42. Remember 3 sig figs. That's important. Even though it's an equation, both of those should have 3 sig figs. That's it. Isn't that amazing? It's so quick. You don't have to do any calculations, and it gives you a perfect line of best fit. If you go back to the graph, so control to the right, there's my graph. Watch this. If I press menu, graph entry, edit, function, and I scroll, oh, it's at F2, but if you scroll up, it's going to have automatically populated F1 with that regression line. And if you press, notice it's not checked, but if you press enter, it'll now appear on the screen. And there it is, a perfect regression line. You can see how it goes through. It perfectly balances, minimizes the residuals. Okay, so that's one way of finding the regression line. Let me show you another way. Remember when we did previous statistics, we used this goofy thing called data and statistics. Let me show you how it works. Let's insert a data and statistics page. So this is an alternative method. Remember, you can press doc, insert, or press escape. You can press, see how it says plus page in blue? So control doc allows me to just add a new page. Look, it's already added page 1.3, and I want to add this goofy data and statistics. I don't like it, but it is kind of nifty, and it has animation. So now there are all the points, they're floating. Well, let me define where they go. So I scroll with my mouse to the bottom X axis, and now I need to select the right variable. Well, the variable for X is distance. Oh, look at them move around. And then I go over here, click on the left axis, and I have to collect time. Can I go up? There we go. And wow, there they go, and they dance around. And now you can see the graph. And then again, if you want to use a regression line, you just press menu, analyze, regression, show linear. Mx plus b is the one that we're interested in. And then it writes the equation right on the graph, and you see the line drawn. So data and statistics page, this is like a special page for doing analysis of data and statistics. I find that you can do everything outside of this, so I don't tend to like it. I find it's all very flashy with the animation. But if you like it, go ahead and use it. So one more way that I can show you how to find the regression, that's with a calculator page. So let's add another page, control doc, go down to calculator. Now we have a blank screen. What do I select? Oh, always menu, that's the key button. And then this time, again, I'm doing statistics. And now I go to stat calculations, and very similar, I go down to linear regression. Now it asks for my X list. I could press var, oh no, I have to use arrow. Is distance, my Y is time. Notice how all these other things appear now. This one's going to save the equation to F2. Okay, that's fine. Press enter. Now the calculator spits out your mx plus b, linear regression, and there's the m, there's the b. That's done. So what I find is that the calculator does all this in much the same way, no matter which way you use, which is calculator mode, data and statistics, or list and spreadsheet. Do it right on the list and spreadsheet. All three ways give you the same answer, and the technique is very similar. One thing I will remind you too, that if you ever want to recover a memory, something you've typed into memory, you can just type var, click var, and then you can find it, right? So if I wanted to know what the distances are, I could press var, then click distance, and it'll give me all the distance values. Similarly, if you want to know the slope of the latest statistical calculation, you can go down to stat m, and it's going to spit it out. So those things are stored and are very easy to get with var. Whew, okay, so your homework today requires the GDC. You cannot do this regression without the GDC. In fact, you won't be, your next test on this, right, your IB test on this will be calculator only, because this is not something we can do by hand. Good luck with the homework, and we will see you next time.